All right, so we've introduced this idea of the Hessian, and what we want to do in this video is actually go through an example of calculating the Hessian and sort of see what it tells us, and then we'll take that back to this question of both how do we approximate multivariable functions and also how do we figure out if we're at a max or a min. So let's choose a function for that. What should we choose as a function, Hannah?
Shall we go back to the old f of xy equals x times y?
I think that's a great idea because I think there's some chance I could actually take the derivative of that function, and that's helpful for me. Like avoiding making really stupid mistakes on videos makes me happy. So, all right, there's the function. One of the things that we should be able to know how to do with multivariable functions is take a gradient, right? So what's the gradient of that going to be?
First coordinate y, second coordinate x.
Right, so we were taking the partial with respect to our first coordinate, right? So, and the partial with respect to our second coordinate, since that's x2, I guess, in this case, or x and y. I'm really being pedantic here, but that's y, x, right? So that's what our gradient vector is. So what about the Hessian? Well, the Hessian is going to have four elements, right? One is going to be the partial with respect to x squared, right? One will be the partial with respect to y squared. And the off diagonals will be the partial with respect to xy and the partial with respect to yx. Right? So, okay, we take the partial with respect to x squared. So we take the derivative twice with respect to x while holding y constant. First time we just get y. Second time we get 0. Right? Same thing for partial with respect to y squared. Right? If we take the partial with respect to x, we get a y, and then the partial of that with respect to y, we get a 1 and a 1 there, right?
Right.
Okay, so we've got this nice matrix, 0, 1, 1, 0. What the heck does that mean?
Well, why don't we look at eigenvectors and eigenvalues?
Yeah, eigenvectors and eigenvalues. Those were sort of a big deal last semester.
That's right.
So let's think about eigenvectors and eigenvalues. And you know, I like this matrix because I can actually figure out what the eigenvectors and eigenvalues are without actually really doing any work. So I propose that the eigenvalues of this matrix are plus or minus 1, and that the corresponding eigenvectors, what's your notation for eigenvectors?
V1 and V2.
Okay, how about V1 is 1, 1, right? That corresponds to the eigenvalue of 1, and V2 is 1, negative 1, or negative 1, 1, right? Which corresponds to the eigenvalue of negative 1. Okay, okay, well, that's interesting, I guess, but what do these actually tell us? Well, let's think for a second about what these directions are, and then what the values of the eigenvalues are, right? So one of the directions, if we go back to sort of picture here, right? Here's our original coordinate system, x and y. So V1 points in this direction, right? And V2, I guess we said negative 1, 1, so V2 points in that direction, right? And if you remember what the function looks like, the function is actually increasing as we go in this direction. So the function is increasing. It's positive over here. It's also positive over here, right? So, and it's negative here and negative here. So if I were to sort of walk along this line, what would I see? The function would go down, and then would go back up, right?
Exactly.
And if I were to walk along this line, right, along the direction of the second eigenvector, the function would come up and then go back down, right? And in fact, if you look at this eigenvalue is telling you about what the curvatures are along those directions, right?
So the positive eigenvalue is telling you about the upward curvature?
Right, so this positive one tells you that you've got positive curvature moving along this direction, and the negative one tells you have negative curvature moving along this direction, right? Is that right?
That sounds right.
Okay.
Sounds reasonable to me.
There are a couple of sort of key things we've got here. One is that the eigenvalues tell you the curvature, and the other is that these two eigenvectors tell you about sort of what the principal axes are for the function around that point. Right?